Today we're only about 96,000 miles away. That's about a third of the distance from the Earth to the Moon. Our destination is within sight, and this team is very excited that we're finally closing in on Vesta. And I'm very pleased to be here today to tell you a little bit about the Dawn mission and about the background on how we got here. If we could roll the first video, you'll see some spectacular footage of the Delta II launch vehicle that started Dawn off on this amazing journey back in September of 2007. And as you watch that, I'll tell you that the Dawn mission is unique in that we're going to be the first mission to rendezvous with not just one body, but two solar system bodies. Many spacecraft have flown by multiple bodies, but Dawn will be the first to make an extended port of call at our two destinations, Vesta and Ceres. These are two of the last unexplored worlds in our inner solar system, and these are large bodies that reside in the asteroid belt between Mars and Jupiter. So if we go ahead and roll the second video, I'll describe how do we get there. Vesta and Ceres, like the planets, are in orbit around the Sun. So to get to Vesta, Dawn is placed into orbit around the Sun, and over a period of months and years, we shape its orbit to match Vesta's orbit. We do this with the ion propulsion system, which is represented by the blue glow that you can see in the video. After launch, we flew by Mars for a gravity assist in 2009, and we completed almost 2 full orbits around the Sun. We'll rendezvous on July the 16th and be captured into orbit around Vesta. We'll orbit Vesta for a year before starting our climb out to Ceres, and then we'll arrive in Ceres in early 2015.
I'm going to talk to you about how we're going to explore Vesta over the next year. This is an unprecedented opportunity to spend a year at a body that we really know nothing about. We're going to do a very comprehensive job of mapping it. In the next animation, we see in a notional sense the spacecraft in its high-altitude mapping orbit. Vesta is rotating at about 5.3 hours, and this is a 12-hour orbit. So we see coming down the lit side of Vesta, taking the framing camera images, which are the blue squares, and we also see that co-located with the framing camera images is the green slit, which is the Vera spectrometer. When the spacecraft's on the dark side of Vesta, it's turning to Earth, and it's sending those data back before it comes around and starts again. We do take these images constantly in swaths as the body rotates under us, and in that manner we build up complete coverage of the surface over 10 orbits. And then we do this 6 times.